Hello and welcome to our lesson on radical expressions and functions. This is going to be from section 6.1 in our text. We're going to start with a general discussion of the terms and conditions, and then we'll move into working examples. So to start with, this symbol is your radical symbol. This is called a radical symbol. The radical symbol has two major components. There's the stuff under the radical, and the term for that stuff is the radicand. So the stuff under the radical is the radicand, and then there's a number that sits in this little crook of the radical, and that number is called the index. So you have the index and the radicand. So the radicand is what you're taking the root of, and the index is the indicated root. So for example, if n is 2, then you're taking the square root. Or if n is 3, then you're taking the cube root. And any higher than that, you would just say 4th root, 5th root, 6th root, so on and so forth. So for example, let's say we have this expression. Notice there is no number showing in the index spot. So one of the things you need to understand is that the index is 2 if there's no number there. If there is a number there, then the index is what is indicated. So here we have the square root. Remember, if n is 2, that square root, we have the square root of 25. So what the index indicates is the number of identical factors that you need to make the radicand. So the two identical factors that multiply to make 25 are 5 and 5. And therefore the square root of 25 is 5, because 5 times 5 makes 25. Or another example, let's say we have the cube root of 27. So here the index is understood to be 3. And so here what I need is 3 identical factors to make 27. 3 times 3 times 3. 3 times 3 is 9. 3 times 9 is 27. So the cube root of 27 is 3, because 3 times itself 3 times makes 27. So now for some conditions that you need to be aware of. Let's say we have this radical expression. Remember, the index, if it's not showing, is understood to be 2, which indicates that I need 2 identical factors to make negative 25. Now, there's a problem here. If the factors have to be identical and I need numbers that multiply to make 25, the choices are 5 times 5, which is positive 25, not negative, or negative 5 times negative 5. Remember, the radical says that the factors have to be identical. So they have to be the same. But negative times a negative also makes a positive, not a negative. So the generalization here that you need to know is that when your index is even, there is no real solution. There does not exist 2 identical factors that will ever multiply to make a negative number if the index is even. If the index is odd, remember that means I need 3 identical factors that will multiply to make negative 27, and that's going to be negative 3 times negative 3 times negative 3, because a negative times a negative makes a positive, and then a positive times a negative makes a negative, which will give me a negative number. So it turns out that odd indexes will produce real number solutions. Okay, first example from our text. Number 7, we have the negative square root of 49 over 36. Now, there is a property of radicals that says if you're taking the root of a fraction, you can actually separate that and do the root of the numerator and the root of the denominator separately. And this negative is just going to hang out front here. Now, the reason I went ahead and split that up is because I noticed that 49 and 36 are perfect squares. Remember, when the index is not shown, it's understood to be 2, which indicates a square root. So the square root of 49 is 7. The square root of 36 is 6. And don't forget the negative hanging out front. And that is done. Now, if I stopped right there, I would be cheating you out of some learning. Let's look at how the Casio ClassWiz can handle this super easy. So we're going to start with our negative symbol, and then we want our square root. And since we're taking the square root of a fraction, we're going to hit the fraction button. And then we simply input the numerator and the denominator. Since it looks the same on the calculator as it does in the text, then this is going to be our answer, negative 7/6. Our next example from the text, number 17, the instructions ask us to approximate the radical expression rounded to 3 decimal places. Now, the way that you're going to approximate a radical expression is with a scientific or graphing calculator. And the ClassWiz is a fantastic tool for this job here. So to input this again correctly, we're going to start with the square root, then the fraction button, and then we simply input our numerator and denominator and equals. And that's going to give us our decimal approximation that we can round to 3 decimal places. 1.962 rounded to 3 decimal places. And that's really all there is to that problem. And if you're wondering what that is the symbol for approximately. Our next example, number 67, we have the fifth root of negative 32 over 243. And the instructions just say find each of the following. So here what they want me to do is simplify completely and give the exact value. So what I'm going to start with is I notice that the index is odd. 5 is an odd number. And the radicand is negative. So that means that the answer will be negative and it will be a real solution. Remember, odd indexes can handle a negative radicand. And I'm going to separate the fraction, giving the numerator and the denominator each the fifth root. And then I simply need to take the fifth root of 32 and the fifth root of 243. Now, again, the Casio does a fantastic job of this. There is a square root and a cube root. I don't know if you can see that in yellow, but it says cube root. And then right above this button, there's what I call the any root button. So we're going to hit Shift and X to the whatever power, and that's the any root, where you can input the index and the radicand. And I'm going to start with the numerator first. So the fifth root of 32 is 2. Yay! So it's a nice number. It has an exact solution. And then let's do the fifth root of 243. So again, that's Shift and X to the whatever. And we want the fifth root of 243. And that's 3. Nice. So now we know that that's going to be negative 2/3. So our answer to this problem is negative 2/3. Now, as a special treat, it is possible to input this problem the way it looks in the text into the ClassWiz. So again, we're going to start with the any root button, and then we're going to input the index, which is 5. Moving to the radicand, we're going to have negative fraction, 32 over 243. And do you see it is possible to input that so that it looks exactly the way it does in the text? And it gives us the answer. This calculator is freaking sweet. Okay, next example, number 43, we have the square root of 16x squared. So this is our first look at an algebraic radical expression. Every other example we've done so far has been strictly numeric. So now we're going to get to see how to deal with variables. So we have a property of radicals that says if you have multiple factors under a root, you can separate them into their own radical symbol. So here I can separate this as the square root of 16 times the square root of x squared. It's almost like Harry Potter, where everybody gets sorted into their own houses. So the 16 and x squared, they get put into their own houses. And then you can take the square root of each one separately. So the square root of 16 is easy. That's 4. 4 times 4 is 16. And this is where I'm going to need to remind you that when the index is not shown, it's understood to be a 2. And now we're going to simplify this part. Now there is a property here that you need to be aware of. And that is when your index is even and it matches your exponent, which is even. If these guys are even, then your answer is going to be absolute value of whatever the radicand is. And I'm going to explain why we have to have the absolute value in a second. So the square root of x squared is going to be absolute value of x. So now here's why the absolute value is absolutely necessary. Let's say, for example, x is negative 2. If I plug that value in to the original problem, we're going to get square root of 16 times negative 2 squared. Remember, negative numbers have to go in parentheses when you evaluate, and a negative 2 squared becomes a positive 4. So do you see this is going to work out and give me a positive result? The square root of a positive number is positive. But if I plug that in here into the answer, but I did not put the absolute value, then I would have 4 times negative 2, which is negative 8, which is a negative answer. And that will not be the same. So that's why you need these absolute value symbols when the index is even. Next example, number 53, we have the cube root of negative 64x to the third. Here they want me to simplify completely. So again, I'm going to separate the factors into their own houses. That's going to give me the cube root of negative 64 times the cube root of x to the third. And then I can simplify each radical part separately. So what is the cube root of 64? Oh, and the fact that the index is odd means that I will have a negative result if the radicand is negative. So that's going to be negative 4. 4 times 4 is 16. 4 times 16 is 64. So the cube root of negative 64 is 4. And for the variable part of this expression, the index and the exponent match. So when the index and the exponent match, they cancel, and we get an x for the answer. If the index and the exponent are odd, you do not need the absolute value on the x like we did in example 43, where the index and the exponent were even. The absolute value is required. Next example, number 23, here we have a radical function, f of x equals the square root of 5x minus 10, and they're going to want us to evaluate. So the first thing they want us to find is f of 6. Now that means to replace every x with a 6. So we're going to have 5 times 6 minus 10. 5 times 6, that's 30 minus 10, which is 20. And then technically, for your solution to be absolutely correct, the radical needs to be in simplest radical form. Now, notice that 20 does not square root nicely. There are not two identical factors that multiply to make 20, but what we can do is we can write 20 as two factors where one of them is a perfect square. So 4 times 5 is 20, and 4 will square root. So this is the way that you simplify radical expressions to lowest terms. If your number doesn't square root, then you find factors of that number where one of the factors is a perfect square. And then we can say, well, the square root of 4 is 2. It's like this. The 4 gets to come out from under the radical, but when you bring it out, you have to square root it. And then the 5, since it doesn't square root, he's left under the radical. So this would be your simplest radical form answer. They may also ask for a decimal approximation, which would require a calculator. Luckily, we do have the Casio Class Whiz. And I'm going to show you how freaking awesome it is. If we type in the square root of 20 and hit equals, the first thing it gives us is the simplest radical form, which is very nice. And then if you need the decimal, you simply hit the SD button, and you can round that to wherever they ask for. If you hit the SD again, it goes back to the simplified radical. So again, this calculator is nice that it gives you the simplest radical form and the decimal if you need it. So rounded to 2 decimal places would be 4.47. And what's going to determine which answer you need is the instructions in the problem or on the test. If it says give the exact value, simplest radical form is needed. Or if it says round to the nearest hundredth, or round to the nearest 2 decimal places, then the 4.47 is needed. Now we have a few more function values they want us to find. F of 2, that would be 5 times 2 minus 10. 5 times 2 is 10. 10 minus 10 is 0. And 0 does square root, because there are two identical factors that multiply to make 0. 0 times 0. And just for fun, any root of 0 is 0. So if the index was 3, you'd get 0. If the index was 4, you'd get 0. So any root of 0 is 0. Next, they want us to find f of 1. So that would be the square root of 5 times 1 minus 10. 5 times 1, that is 5 minus 10, which is negative 5. Okay, so now let's think about this a second. If the index is not showing, it's understood to be 2. If the index is even and the radicand is negative, that's going to be no real solution. So there is no real solution for this problem. And if you're wondering why I keep saying real in there instead of just no solution, there is a solution, it's just not real. And you're going, what the are you talking about? Well, if it's not real, it must be imaginary. And that's when we get to complex numbers that you'll actually get a solution when the index is 2 and the radicand is negative. But for right now, we're just going to say no real solution. And last, they want us to find f of negative 1. So that's going to be 5 times negative 1 minus 10. Don't forget that negative numbers need to go in parentheses when you evaluate with them. 5 times negative 1 is negative 5. Minus 10 is negative 15. And again, an even index with a negative radicand produces a no real solution. So that also has no real solution. And I think that's going to do it for this particular lesson. So if you have any questions or comments about anything that I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.